Hello everyone, my name is Marcin and I'm working with GerritForge, and together with Alvaro we're gonna show you the new cool features in the pull replication plugin. So that's the agenda. So I want to give a very high-level introduction to the pull replication plugin, then we're gonna go through the new features. I'm gonna stop on the bug fixes, and then Alvaro is gonna take over from me. And let's imagine that we have 4 Gerrit nodes. From the pull replication perspective, it doesn't matter if it is a replica or primary node, if they are all active-active, or we have just active-passive. And when we have a ref update, so for example, someone is voting on a change, Gerrit is gonna, pull replication is gonna send a notification to all the nodes that there is a new piece of data which they need to fetch. And it's gonna be done by the REST API call. So all the other nodes gonna receive that call, and they're gonna trigger the Git fetch to basically update their site. There's another feature on top of that. So we started looking how we can improve the performance, and we noticed that sometimes the data size which we need to transfer with the Git fetch is so small that there is no point of triggering extra Git operation, that we can actually read the data, serialize it, and send it over with that REST API call. We call it apply object. I'm mentioning that because we had few improvements in this area. So yeah, that's basically how the pull replication works from the high-level perspective. And why we even implemented pull replication. So there is a push replication plugin. It's called actually replication plugin for the historical reason. And it's in the Gerrit ecosystem for a very long time. It works really well. It's adopted by many companies. But the problem with the push replication is the nature of the Git protocol. So push is always slower than fetch in Git. So even for our Gerrit repository, which has like 45,000 refs, push replication on my laptop takes 10 seconds sometimes. And at the same time, for the same amount of data, pull replication fetch takes 1.5 seconds. And apply object, it's 50 milliseconds. So as you can see, we can get some improvement in terms of performance. So it's especially important if you want to have active nodes, because you want to transfer the data to the other side as quickly as possible to have this period of time where the nodes are not in sync as short as possible. Okay, so but what's gonna happen in one of the nodes? So we are moving to the first new feature. So what's gonna happen if one of the nodes gonna go down? Remember, I said that we notifying other nodes using the REST API calls. So if the node is down, it cannot receive those calls. So this means that when it's gonna go up again, it's gonna be outdated. And it's not gonna know that it needs to fetch new data, that there were some changes. So before this new feature, we were always recommending to go with the push replication. So push and pull replication, they can work together. So when the node is down, it's not accepting the REST API calls, but when it's gonna it's gonna be available again, the push replication finally is gonna transfer the data. But we thought, how we can make them less independent, so maybe we don't have to use the push replication with pull replication all the time. And we figured out that there is actually a cool functionality which was introduced for the multi-site, which is called event broker. So whenever we have ref update in Gerrit, Gerrit is going to generate an event. We call them stream events. And with the event broker, we are able to stream those events through some kind of external broker. I'm going to talk about that a little bit later. So this means that our pull replication plugin can listen on those events and trigger the Git fetches. So when the node is down, it's of course missing the REST API calls. But when it's available again, the messages are waiting for that node in the events broker. So we can just start reading those messages and start to call fetch operations. So the next point is why we still need REST if we have event broker. And for two reasons. First, we are not ready yet to discard the REST because we're still missing the apply object through the events broker. So the stream events were given for free. They are already implemented as a part of the multi-site. But apply object not. So we have to create a new topic and start streaming those apply objects with the data. So it's on our roadmap. We're going to implement that, but it's not done yet. And the second thing is that REST is going to be always slightly faster than events broker. With event brokers, we always have the overhead of sending the message through external system. And here we are talking about milliseconds for the apply objects, for example, so we want to make it as fast as possible. Yeah?
Yeah, a question about that. The first one is, how do you know when you can use the apply object and fetch isn't necessary?
So we have this property where we are defining how big, in terms of size, the data must be to trigger the fetch. So if the change is small in terms of bytes, we are using apply object. If the change is bigger than the certain limit, we are always triggering the git fetch. So that's how it's done.
I want also to add one remark that the apply object has been explicitly designed to replicate the metadata. So when you go to NodeDB, you have immediately a lot more ref updates compared to what you had before. And the problem is that we have added all this information in NodeDB, and NodeDB becomes really volatile, but Gerrit didn't improve in replication at the same time. So we have seen that the customers that they go to NodeDB, but they still use the traditional replication, they start having a spike of replication times, and then they can also see replication times that they are getting delayed for sometimes even hours, because you want to replicate something, but there is already another push in queue, and then you have a conflict. And you keep on delaying that replication. And when you need to replicate metadata, you know already the shape of the data, the size of the data, and you know already, let's say, how it looks like in terms of dependencies. So that's why apply object is 1,000, if not 10,000, or even 100,000 faster than regular replication for that.
Yeah, but we use apply object also for the regular data, so not only for the metarefs.
There are other three questions on that. So can apply object be done via message broker instead of REST?
Not now, but we are working on that. So we have all the machinery, and we have a plan to implement that. It just haven't been done yet, but yeah, that's our plan to implement that.
And another question is it configurable, the data size to trigger to skip the git fetch and do apply object?
Yes. It's a configuration parameter. Event broker. So the event broker is done in that way that it's a Gerrit library which you can deploy, and then you can provide the Gerrit events broker plugin, which is giving you a concrete implementation of that library. So we have Kafka, Kinesis, and gcloud PubSub. And together with event broker, we have this stream event publisher module. So if you're going to instantiate that module, it's going to start streaming the events to the events broker. And then when that's done, the only thing you have to do on the pull replication side is to enable it. So there is just one param, you're setting it to true, and then that's it. So we're going to start consuming messages in pull replication, and we're going to start triggering the fetch operations. Why apply object is so fast? Because we don't have to do the git fetch. We're going to have to trigger the git fetch protocol, which is doing the negotiation part. So we don't have to exchange the refs descriptions between server and client. We are taking the data, we're checking if the parent is there, and we're just writing it. So that's why we could get milliseconds here. But sometimes the parent is missing. For example, we have two nodes. One node is getting offline, and someone on the other node, which is still healthy, someone give -2. Then, and the events broker wasn't enabled, so there is no event. We lost that information. Push replication is not there as well. So when the node is become healthy again, it's outdated. And then when someone is gonna give +2 on the same change on the previous node, we're gonna try to send the data with apply object, but we're gonna miss the parent. We have a gap in a chain. And before that fix, we were always falling back to Git fetch protocol. So this means that we were triggering Git fetch protocol, which was doing the full exchange of refs. It was trying to find a common base. Of course, there is a gap, so it's not able to find a common base, so it's advertising all the refs to other sides. The other side is advertising all the refs. It can take minutes sometimes, but it will eventually fill the gap, transfer the data, we're gonna be in sync. But we thought like, that's a kind of problematic for us. So maybe we're gonna help Git fetch protocol a bit here. So when the apply object fails, we do not fall back immediately to the Git fetch. We are notifying the sender that, there's the situation that we don't know the parent. So what the sender is gonna do is gonna read all the chain of commits for that specific ref, and it's gonna send it again to the client, to the receiver. And then the receiver can apply one by one, so it can fill the gap. If that's not working for some reason, we still can do the fetch. Fetch is always an option. And that's why it's slightly slower than single apply object, but it's still way faster than Git.
If you have push replication and pull replication at the same time, and the push replication starts, but the pull replication is faster and gets completed. The push replication is working not in milliseconds, it's working in seconds, minutes, or even more. And basically, the push replication doesn't even do negotiation. So it means that the client thinks that the server needs something and start pushing to it. Push replication goes behind Gerrit's back. So it means that it goes straight to the file system. Gerrit is not even aware of what's going on. And from your sender perspective, was all fine. So you push what you think was worth to push. But when it's getting executed on the other system, maybe the pull replication succeeded, and the push replication was actually maybe half an hour behind. What push replication is doing is rewinding. My suggestion would be, if you use push replication and pull replication together, you need to have a good reason. And if you have a good reason, you need to understand what are the implications. And if you don't have a good reason, stop using push replication. Because if pull replication is 1,000 times faster, why do you want to go slower? Yeah, there is another question. Can REST API and stream events consumption be enabled at the same time? If so, what mechanism, when a fetch has already happened, over a different mechanism? So it means that, do you do it concurrently? Yes or no? And if you do, what happens if, so you get one when the other arrived already?
So, so for now, they're always going together. So they're done concurrently. And we are based, in JGit, we have the locking mechanism. So that prevents us to have multiple writes at the same time. And the fetch, if the fetch has the data, the negotiation process is going to include that data, so there will be nothing to fetch, basically. The other thing is that we cannot set up pull replication as a standalone service. So sometimes I know that our clients have like replicas where there's just a Git daemon, so they still need to use push replication if they want to replicate. Some clients are replicating the backups like that, so that's not possible with pull replication like yet, because they need a Gerrit instance.
When we started working on the pull replication is because basically whenever we were talking about these with Sean, with Dave, with the other Google guys, they say, yeah, but we don't use your replication. I say, which one do you use? Can we use the same? No. Okay, can you tell us how it works and we write the code? And that's the pull replication plugin.
We also took an effort to look into that part of code and try to improve it. So those are the few things we managed to find. For example, we noticed that when we were trying to fetch Gerrit meta refs, which is a special type of ref, it's an orphan ref. This means that it doesn't have any parents. It was taking 20 seconds just on the Gerrit project. What we noticed that if there is no parents, the JGit works in that way that it's still trying to find a common base, and it's not able to find a common base because there's nothing, but it still tries to advertise all the refs. So just improving that. So for the orphan refs, we don't do that anymore. When the server receives the request to get that particular ref, and it sees that there is no parents, it's saying, okay, so you need just that piece of data. You don't need anything else because there is no link. So it's just going to stop doing the advertisement. That brings the time from 20 seconds to 1.5 seconds for the meta refs, for the fetch. Another feature was to doing the shortcut during the loop for the refs, non-commit refs, which they're like they don't have any parents or successor, or they're a tip of the ref. Checking the reachability of that object was taking up to 30 seconds on a large repository, on 2 million repository. This means that to retrieve the data, it took 50 milliseconds, but actually to check the reachability, it was taking 30 seconds. So when we analyze what's happening, we came to this conclusion that for some operations, for some type of objects, we don't need to check the reachability. As I said, when there is no parents, there is no successor, we don't have to check the reachability. When you're on the tip of the object is on the tip of the ref, we don't have to check the reachability. So that allows us to basically skip that 30 seconds. The last one was also, it's not strictly related to the Git fetch, but we noticed that every time we were loading the packref list, we were doing three things. We were reading all the data from the sorry, I forgot about one thing. The trust folder stat is set to false, and it's quite common in our setups to have trust folder stat set to false because people are using NFS systems. So when we have NFS with, for example, with HA plugin, you need to set trust folder stat to false, and then whenever we were reading when someone was doing the lookup for a ref, he was doing those three things. It was loading everything from the disk. It was calculating the SHA-1 of the full content, and also the objects were created in memory for those refs. So just by keeping the raw content of this ref list in memory, and then reading it from the disk and checking byte by byte, if it's different, we managed to, and if it's the same, skipping point 2 and 3, we managed to get even 10 times faster lookups. Yeah, so basically trust for stat, when we are checking if there is any modification of the data, we're checking the modification time of the directory, and with the NFS systems, sometimes the modification, because there is always a distributed cache on top of the distributed file system. This one can have a delay with replication. So the modification time, even if the data is actually visible on the other side, when you have two nodes sharing the same NFS, the modification time sometimes is not changed. Because of this distributed cache synchronization. So if you're gonna set trust folder stat to false, you're not gonna check the modification time of the directory, but you're gonna go directly to the file system to read the data, to check if there is something new there.
I have to say that trust folder stat is really a killer for performance. So if you really have to enable it, sometimes you have to, because if you don't do, you corrupt the repo. So what do you like most? Having a corrupted repository or being slow? So between the two evil, maybe slower is less of the evil, But if you really have to, then even if it is not merged, I will strongly recommend the last optimization. So because it's providing such an increase of performance that is a no-brainer. So the reviews, because I will tell you why it's not merged, because it's using more heap. Instead of computing SHA-1 every time, basically in storing in memory the image of the pack file, and is comparing the data instead of computing SHA-1, which is surprising. That is faster comparing, let's say, 200 megabytes of data than using SHA-1, the implementation in Java.
So the question is, it would be help if we try to revert the change Sean did or SHA-1 security?
No, because we still want to prevent the collisions. So we still want to have this functionality to prevent the collisions on the SHA-1. Yeah, so I think the fix is going to be that there will be a parameter in the JGit where you can decide if you want to use the native SHA-1 or you want to use our custom version. So if you can explicitly turn it off and use the JVM SHA-1 algorithm. But yeah, but that's not done yet, I believe. Okay, so while we were doing all those optimization, we noticed that there is a room also to improve the metrics. So the left side was in pull replication like since the beginning. So on the left side, you can see like two graphs. First, it's the fetch latency, which shows how long it took to do the git fetch. And there is also apply object latency, which shows how long it took to get the data and write it to the repository. On the right-hand side, we have the new metrics, and there are showing like the bigger picture. So for the fetch, it shows it starts from the moment when you're starting reading the data from the local repository. We are checking if the data are gonna fit to apply object. If not, we are triggering the REST call, and then we are triggering the fetch. And when the fetch is finished, we are recording the latency. So it's like the full cycle. Same for apply object. So we are reading the data, sending, writing, and then that's the latency. So that can help us to understand where is the slowness. So for example, if we see that the end-to-end latency is going up, but the fetch latency is not going up, this means that our git fetch operation is fast, but maybe reading from the data or sending over the wire, maybe there's some network problem, we have slowness there. Same for the apply object. We can, it helps us to understand what is going on. And yeah, we're actively working on the pull replication. So since the last presentation, we did like 30 bug fixes and improvements. I just put a few of them. So for example, we unified the way how we are identifying our nodes. So we are not using the pull replication specific property called instance label. We started using Gerrit instance ID, so it simplified the configuration. We finally fixed this annoying issue with fetching all refs after project creation. So there was a problem that when you created a new project, the project was created on the other side, but then we wanted to fetch all the refs of that project, and we were using wrong ref spec. It was failing, so now it's fixed. I don't know why, but in the first version, we didn't allow apply object for non-commit refs, and we have few of them in Gerrit. So now it's done. It works for all refs. We added some logging, so it's easier to understand what is going on in the system. Fine. We can also remove the refs, and yeah, fix some issue with the ref deletion when the global refdb is also there. Okay, yeah. I'm gonna hand over to.
Okay, my name is Alvaro. I work for GerritForge since August. So I'm a newbie. At the end of the day, I'm a beginner in all this world, but yeah, I'm very excited. So the first thing I want to do before I start is I want to thank Luca for organizing this summit, for giving me the opportunity to work in GerritForge with these people that are really, really top engineers. And I want to thank you, all the rest of the people that presented, because it was amazing. I learned a lot. Yeah, I'm using this space as an individual to thank everybody for that. In the REST API that we are using in the pull replication plugin, and when the Git fetch is through HTTPS, right now, basically we are using the basic HTTP authentication, which I know that all of you knows easily, so I'm not going to go in details on this. So this is the way that we manage the authentication. So right now, currently for configuration, it's GerritNode. So basically there are two mainly files. One is the replication.config, where we configured, we have different sections, remote sections, where basically we defined all the properties related with how will be the replication or how will be the fetch. So, and at the same time, in the secure.config, we need to define the username and the password that basically we will use when we use HTTPS. Basic for everybody, but just to let you know that basically is a little bit tedious to configure that, right? In order to replicate, the user and password is provided in the request in the authorization header, need to be checked in the server against the accounts that are stored in the all user repository, right? So, but the all user Git repository need to be replicated across all the Gerrit instances. So, okay. So I need basically to be able to check the account, I need to have the repository replicated to be able to use the pull replication, but I need it. But to be able to have the repository there, I need to do it before. So it's like some kind of like a chicken egg problem. So which when we deploy, in any topology that we had, multi-site or one site with multiple primaries, replicas. So it requires some previous steps in the deployment process to be able or to allow the pull replication whenever it starts working to have replicated the all users repository already in place. So maybe Marcin, if there is time, can explain a little bit more how he has done in some clients. So then we get to the point we say, fine, this works perfectly, but basically we need to take some extra steps to make sure that everything is already in place before I can start using this plugin, right? So then that makes us think to say, can we find another way to do this that can help us, or even to have some kind of peace of mind and make, at the end of the day, we want to automate, the more the better, but at the same time we want to do the less steps the better, just because the more steps you take, probably more probability you have that you can fail, something can go wrong, right? So then, so the first motivation that we found is, okay, can we provide a simpler machine-to-machine authentication? Can we simplify the plugin configuration, because now we need a bunch of remote sections in the replication.config that this is unavoidable, but do we really want to have this kind of coupling before those files with all the risk that that's supposed? Because some extra steps that it can fail, so could become very brittle. So in that way, we will simplify the deployment process, right? So, and at the same time, we want to find a solution that keeps its backward compatibility with the basic HTTP authentication, right? So then, speaking about that, thinking about that, Marcin suggested, why don't we use the bearer token authentication? But the point is, we don't want to replace the basic HTTP authentication. We want to provide another method of authentication. So then it's up to you. We don't want to break anybody, right? We want to evolve, but at the same time, we want to allow people to configure their environments in the way that they wish or how they feel comfortable. Maybe people has already an automation process where they feel comfortable and they think that basic HTTP authentication is is good enough, and if they feel comfortable, everything under control, fair enough. But just to let people know that we have another way of doing it, right? For me, in this case, the bearer token authentication is more like a machine-to-machine authentication, right? And we don't want to be involved with the Gerrit account stuff, right? It's like we were trying to solve probably at the beginning one problem was something that was already there, but now we want to move away from that and basically, like you said, to add a layer of security. So then, okay, so the bearer token authentication is coming in two flavors, right? So one is the REST API that is already implemented, and the other one is the Git protocol, which is in progress. So, but yeah, it will be finished in weeks. Just let you know that the REST API flavor is already in pull replication 3.4 and is merged in master. It can get complex, but we wanted to do something at the beginning as a first step, like something very straightforward. Bearer token, where the token basically is going to be as a string, as it is. It's not even encoded for the moment, and is anything fancy, right? So because if you go to all the Auth2 documentation, it could become complex, and we say, okay, we want something simple, machine to machine, and that's it. So the configuration is easy, right? So basically, it's going to be one section. Instead of the auth section in secure.config, we are going to have the bearer token. Obviously, when we deploy and we provision, we'll have like a secure method to load secrets from AWS, GCP, or whatever. So everything will be fine. So basically, we have basic HTTP authentication, where the authentication is done by the project basic auth filter. So the bearer token authentication, we have a new bearer authentication filter responsible for the authentication itself. So the authorization in both cases is done. It's a little bit more complex than that, I have to be honest. But I wanted just I didn't want people to get confused. But we could say that mainly used in the REST API servlet class. The URLs, the basic HTTP authentication has the prefix /a, and the bearer token authentication don't have that anymore. Just is like a remark. As I said, the intention that we have from the day one is we don't want to remove the basic authentication, the basic HTTP authentication. We want to allow everybody to choose one or another, right? So in the client that start the HTTP request right now is going to say, if the bearer token is defined, we use it. If not, we will use the credentials. Obviously, if nothing is in place, so probably what it will do is like an anonymous request where we'll fail in the server side with a 401 or a 403, depending on the use case. So in terms of the bearer, in terms of the site, the server side, the filter is going to check that if the bearer token is properly authenticated. What we do is we create a context where we create a plugin user that basically represents the machine as a machine, right? So, and we provide, we assign the REST API credentials, we could say. And in the case that the bearer token is not matching, so we provide a 401. In the part of the authorization, so we retrieve the user, and we check, in this case, because contains the REST API authorization, it will move forward to the next step.
One question is, would be nice if we could use MTLS to authenticate requests from replica the masters in the same cluster instead of basic code. So have we thought about using also mutual SSL authentication, TLS authentication?
Well, not me, but eventually at the end of the day, it's a feature that if the community thinks that is important, I think it's a good feature. So yeah.
Yeah. The second is, do you need an OAuth server for using bearer token?
No. With the bearer token, it can get very complicated. So it's pretty straightforward. So all the nodes in the topology or the cluster, so we'll have in the secure.config the bearer token defined, loaded from secrets, whatever, and basically at the end of the day, it's a matching of strings. So we could provide encoding and more sophisticated things, but the first version that we have is just a string. So that's it. Nothing, we don't need to go to any auth service to fetch. We don't need to decode and then go to the auth service to check credentials. No, it's pretty straightforward.
Do you have any code in place for expiring the bearer tokens?
Not yet. Not yet, but as you mentioned before, eventually we should have it.
So in meantime, I can also, because there was a question how we are dealing without the barrier token so far. So when we are deploying the pull replication, first thing, there is a prerequisite, so the user needs to be created. So we need to have a user and password already in all users. And if we are adding the pull replication to the setup which is already multi-site or the multi-server, we usually have the push replication already in place. So the push replication can push the old projects, and then the user and password is going to be replicated their site. But it's giving some extra overhead which we don't need with barrier tokens. So it's definitely a good idea to have that.
Imagine that all your backfill mechanism failed. So imagine you missed the apply object because the other node was down. There was some network issues, and that kept on failing for a week. That is the replication time for Kafka. Can the Gerrit admin still force the fetch of all refs as they do at the moment with the push replication? Is there a command to say fetch everything?
Yes, in pull replication we have a SSH command which you can trigger, which is gonna basically trigger the fetch for that project.
In Java Melody plugin, we also have Bearer token, but it's to scrap data from Prometheus. So not to authenticate against Gerrit, but so I guess those are unrelated Bearer tokens, right?
Yeah, so those are two different plugins, so they have two different configurations. But to be honest, we were looking at the implementation of that when we were.
Yeah, so maybe if we start introduce yet another Bearer tokens for 25 plugins, maybe we can consolidate it.
Yeah, we could, but we have to discuss that because this barrier token is also on the Prometheus side. So maybe for the security reason you want to have a separate barrier token. So we have to discuss, if that's secure. Was one more question?
Good. Hey, Marcin.